Imagine that. We use a cannon, fire the projectile vertically upward, then the shell will stop as the altitude increases, then return to the ground. If we want the cannonball to fly completely off the Earth, you need a fast enough speed. This is the escape velocity. For the Earth, the escape velocity is 11.2 kilometers per second. The concept of escape velocity, an attractive force from Isaac Newton, he believed that any object had an escape velocity. This speed depends on the mass and attractive force of the object. For example, Jupiter is 318 times the mass of Earth, so pottery from Jupiter takes 59.7 kilometers per second. Pottery on the surface of the Sun is faster, reached 615 kilometers per second. However, there is an escape velocity of celestial bodies. Not even the speed of light can escape. It's the black hole. The black hole is Einstein, an allegorical celestial body in general relativity. But it was actually as early as the 18th century. British astronomer Mitchell once speculated that if a celestial body is massive enough, its escape velocity may exceed the speed of light, so that the luminosity cannot escape. At that time, he called such celestial bodies dark stars, and then the black hole. So, why is the escape velocity of a black hole not even light can escape? So let's start with this. Let's first understand how a black hole is formed. Generally speaking, black holes are created by the death of massive stars. We know stars emit light and heat. It is hydrogen that binds under high temperature and pressure in the core, harmful fusion reaction, at the same time release a huge amount of energy. However, the fuel in the star will one day run out. That is, they will change step by step, from the original hydrogen saw to the C, from saw to carbon, from carbon saw to iron. But not until the iron stops sawing, because iron atoms are very stable. This makes the star is not massive enough to trigger the sawing process, so there is no source of energy. The balance of the star's attractive forces will be upset, then attractive forces will prevail, cause stellar beach pine. In less than a second, the whole star shuttles to a tiny state, then there was a violent explosion. This kind of explosion is also known as a supernova. After the eruption, the center stays a dense core. If the mass of this core more than 3.2 times the mass of the Sun, then it will collapse into a black hole. So a black hole is a small object. They collect a lot of mass. This density becomes unimaginable. For example, if we want to put the Sun 1.40 million kilometers in diameter compressed into a black hole, its diameter is reduced to at least 3 kilometers. Again, if we want to compress the Earth into a black hole, and it's only 9 millimeters in diameter. So back to that, why is the escape velocity of black holes even light cannot escape? Which brings us to the attractive force of black holes. It says black holes are formed by the collapse of massive stars. In collapse, all matter is compressed into a dense core. Here the neutrons are even crushed into powder. This makes an extremely attractive force. But why can't we escape? Einstein's general theory of relativity provide us with an easy-to-understand theoretical basis. He told us that the nature of attractive forces, it's actually caused by the curvature of spacetime. It gets bigger and bigger, the greater the rate of curvature of spacetime. For example, in our solar system, the reason why a heavenly body revolves around the Sun, because of the mass of the Sun, bending the surrounding time and space, altering the trajectory of these celestial bodies. And the immense mass and density of black holes, putting the curvature of spacetime to its limits. After light enters the vicinity of the black hole, it travels through extremely curved spacetime, make it impossible to escape. Finally, it falls into the starting point of the black hole. Therefore, we cannot see the black hole with the naked eye. It can only be discovered indirectly. Like when a black hole swallows matter, it rubs around, suction plate that generates high temperature, that's where we'll find its tracks. For example, when you observe distant celestial bodies, the celestial body orbits an invisible source of attractive force. The existence of black holes can also be speculated.